So why would I use the term isometric networking? Well, it's simple, of course. Along with my last name, it spells out win. But honestly, it's kind of describing geometry and motion. That's what it breaks down to. Um, just the geometry trying to equalize over the entire universe. Um, so, in my previous video, the Holy Grail of Physics for Real, it goes into a lot of these things. It's hard to understand. Of course, I don't describe anything very well in that. This is kind of a deeper dive into to break it down a little easier, so it's easier to digest. I mean, right now you're looking at it and it's just basically a whole lot of words and a lot of numbers. So let's see what that actually means. Okay, so we're going to break this down so it's nice and simple, easy to understand. Let's strip away everything except for one object. The only thing in the universe is this one object. It's object A. Object A is traveling at 100 miles an hour. Is it? From object A's perspective, it's not moving at all. Then there's nothing to look at, so it can't be actually moving, right? If that makes sense to you. Hopefully it does. Since, I mean, the only thing that says it's moving is the fact that I gave it that arbitrary number. That's it. So, what I'm saying is object A is always in its own here and now. It's a one-to-one ratio from its perspective. It has no other perspective until we insert object B. Now, object B is traveling at 50 miles an hour in the same direction as object A. So, if you look at it, from object A's perspective, object B is traveling away from it at 50 miles an hour. If you look at it, object A from object B's perspective, object A is moving away from it at 50 miles per hour. Does that make sense? So now object A knows that object B is moving away from it at 50 miles an hour. And object B also knows that object A is moving away from it at 50 miles an hour. The distance between them is growing at a rate of 50 miles an hour. So, which one of these two objects is actually moving? Either one of them? Is it object A or object B? So, I just want to point out that no matter where you go, you are always right here and now. Your perspective is always here and now. So, since A isn't moving and B isn't moving, the only thing that's changing is the distance between them, the space that is between them. It is increasing, right? They have more space between them as they are going 50 miles per hour apart from each other. So I hope you're all still following along with what I'm saying, but now we're going to go ahead and put in object C. Object C is traveling perpendicular at a 90-degree angle from the path of travel of A and B away from that line at 10 miles an hour. So, from object C's perspective, object A, if you use the Pythagorean theorem, object A is traveling away from object C at not 110 miles an hour, because A squared plus B squared equals C squared. But we're just talking about the line of travel. We're not talking about object B. Anyways, so it comes out that A is traveling away from object C at 100.5 about miles per hour. From object A's perspective, object C is traveling away from it at 100.5 miles per hour. But object A um, from object C's perspective, is traveling away from object C at 100.5 miles per hour. You with me so far? So what about B and C? I mean, it turns out that B is traveling away from C at approximately 51 miles per hour. So from C's perspective, B is traveling away at 51 miles per hour. So, C is, of course, in its own here and now. And B looks at C and sees the same thing. They're traveling away from each other at 51 miles an hour. So what's actually changing here? Again, it's all the geometry. The space between these objects is what's changing. And it's a relational change. So which one of these things do we actually give the energy to? Which object do we give the actual energy to? Kinetic energy. One of these things has to have it, right? So if an object is traveling in a certain direction, it changes the amount of energy that everything else in the universe has based on the direction of travel. All the stuff in your line of travel, the energy increases, and all the stuff that's not, the energy decreases, right? That's just silly. So why don't we put the energy where it actually belongs? I mean, it's just our observation of the geometry interacting with the matter. That's it. So I know I oversimplified this a whole lot. There's a whole lot more going on in the universe than what was talked about here. But I mean, I stripped it down as much as I could to kind of explain how things are working. I kept out time dilation because that would just make it even more confusing. Anyhow, I hope you enjoyed it. Thanks for watching.